Okay, so in our previous video we talked about how to find combinations and we used an organized list to do that. Now we're going to talk about a shortcut to do that. We're going to talk about combination notation. This is one of those things that, like, when you see it, it looks really weird and complicated, but it's actually not very difficult. So just bear with me with an explanation here. So if you remember in the first video, we had these toppings of fruits, and there were 4 different toppings, and we were choosing 2 of them at a time. And so we can do a problem where we can find the number of combinations by taking the total number of permutations divided by the factorial of the number that you're choosing. Okay, that might sound hard, but let me show you how it'll be written. We'll write it as like that. The combination of that number is equal the permutation divided by the factorial of the amount chosen. Okay, so this, for our toppings example, okay, we have 4 options. We're choosing 2 at a time. So it would look like this. I'm going to write it over here. 4 options chosen 2 at a time. That's just our notation to show combinations. And then we're going to put our total number of permutations here. Well, we're choosing 2, so we should be doing the permutation of 4 options chosen 2 at a time divided by the factorial of the number chosen, so the factorial of 2. Which, we talked about all of this in the last lesson, so if you're a little fuzzy on that, you might want to go back and watch the videos about permutations. But to solve this, all things that we do is we have the number 4, and we got to multiply it by the number behind it. You're just doing 2 of them, so 4 times 3. And factorial means you multiply by the number that you have all the way down to 1. So in this case, it's just going to be 2 times 1. And so that's how you would solve it. So 4 times 3 is 12, divided by 2 times 1, which is 2, and then 12 divided by 2 is 6. Which you can see, 6 combinations is exactly what we got when we did this one. Okay? So let's look at another example. Okay? So the problem that we're going to look at, I'm going to write it down. Okay, so the problem we're working with is here. A fishing boat uses 5 fishing lines. There are 12 lures. How many different combinations of lures can be used at one time on the boat? So in my very fancy drawing here, I have a fishing boat, and see it's 5 fishing lines. So here's the strings that they're going to hang from. We have these 12 lures to choose from, and you can only use 5 of them at a time, right? Because there's only 5 poles. So the situation here we can show like this, all right? We can say we have 12 lures, that's the number that we have, and we are choosing them 5 at a time, okay? So 12 lures chosen 5 at a time. So then what we're going to do is we're going to find the permutation of this, the permutation of 12 chosen 5 at a time, and divide it by the factorial of the number of choices, okay? And that's a 12, not an R. I realize on the camera it looks kind of like an R. There we go. So to write that out, that means I'm going to start at 12, and I need to go down 5 times. So 12 times 11 times 10 times 9 times 8, like that. So there's 5 of them. And then I'm going to divide it by 5 factorial, which means I multiply by 5, and I'm going to go all the way down until I get to 1. So 5 times 4 times 3 times 2 times 1. And if you have a scientific calculator at home, you can use parentheses. Well, I guess I could do it on here, but it doesn't work as well. You can use parentheses around these and then divide it by this in parentheses, and it'll do it for you, but I'm going to do it out manually. So 12 times 11 times 10 times 9 times 8. So on the top, we end up with 95,040 And then here we're going to do 5 times 4 times 3 times 2 times 1. I get 120. And so I'm finding out the number of combinations I could use here. So now I need to take this 95,000 number and divide it by 120. And so there are 792 different combinations. So I could write my answer like this. The combination of 12 lures chosen 5 at a time is 792. There are 792 ways you could mix those 12 lures amongst those 5 fishing lines. So this is exactly why we use combination notation, because can you imagine if I had made you write out an organized list for all of these? And I mean, it took a lot to come up with this list that just had 4 combinations. Can you imagine what the list would look like for 792 combinations? And so that's how you use combination notation. So I'm going to give you a couple more, and I want you to pause the video to work through these ones. Okay, they're not going to be story problems. I'm just going to give you the combination notation, and I want you to solve it. Okay, so this is the combination of 7 objects chosen 5 at a time. I want you to figure out the combination of 8 objects chosen 4 at a time. And then finally, I want you to figure out the combination of 5 objects chosen 3 at a time. So go ahead and pause the video to do the work and then restart to check. All right, so these are the problems you should have come up with. Since it's 7 objects taken 5 at a time, I should have on the top started, I should have found the permutation of 7 objects taken 5 at a time. So 7 times 6 times 5 times 4 times 3. So I'm starting with 7 and I'm counting down 5 numbers. And then on the bottom I have to do the factorial of 5. That's going from 5 all the way down to 1. 5 times 4 times 3 times 2 times 1. So then when I go to do that, I should have gotten 2,520 over 120. Press equals. And then I'm going to divide those. And so for this one, the answer is 21. There are 21 different combinations when you have 7 objects taken 5 at a time. For this one, we have 1,680, and it's going to be over 24. So 1,680 divided by 24. So when you have 8 objects and you're taking them 4 at a time, there are 70 different combinations you could come up with. And then finally, when you have 5 objects and you're taking them 3 at a time, this is what your setup should look like. We're going to have 60 divided, I already know that's going to be 6, because 3 times 2 times 1 would be 6, and then 60 divided by 6 is 10, and so you would have 10 combinations there. So that's how you solve for combinations when order does not matter.